All right, thank you very much for coming to the Autodesk booth, and welcome to NAB 2010. My name is Bill Ennis, and we're going to put your glasses on, if you have glasses, to look at the open. That's our digital entertainment creation graphics in stereo. So very cool. Hi, everybody. Welcome to the Autodesk booth. My name is Bill Ennis, and for the next hour or so, I have the pleasure of taking you through a very cool presentation of a lot of the cool new features inside of Flame 2011. Looking back at the evolution of post-production, we can see that we've gone from standard definition, if I click again, from standard definition to high definition to digital intermediate workflows, and today the industry is rapidly moving towards stereoscopy. And if we look back at the last 6 releases of Flame, you can see that Flame is evolving and adapting with these trends. And in Flame 2011, brand new tools like pixel shaders and substance textures and new functionality like stereoscopic 3D have come into the application, and it's a really huge release. And during the evolution that we've just come from we remember back when we were having the biggest challenges were like A over B compositing. And today there are much more complex workflows that incorporate a lot of 3D generated elements. So we need a much tighter integration between 2D and 3D, from 3D design all the way up through 3D visual effects finishing. And this is why you need a system like Flame, because it can deliver a high level of precision at a very high speed while maintaining the highest quality. And Autodesk is really the only company out there that can provide solutions that go from pre-visualization all the way through to delivery. And this is what we like to call the creative 3D finishing pipeline. And of course today, what we're talking about is Autodesk Flame in the context of working with Autodesk Flare and also Autodesk Maya to set that pipeline up and to do our creative 3D finishing. So with that introduction, I'd like to get directly into a conversation about the new features. So is that right, Toba-san? Do I need to move forward one more? That's just right. Okay, so let's get into the desktop. We've got a lot of different examples. Before we get started, I want to thank 2 companies that provided material for this. CBS Digital Inertia in Hollywood and also McRae Laboratory in Japan for providing some of these different elements that we'll be using. So let's start talking about the new changes inside of the application. I'd like to start by talking about the improved media access. Things like R3D or RED files can now be brought into the application, as well as H.264 and other compressed media formats over the gateway. And if you go into the network, you now see there's a new entry below the frame store. You won't need your glasses for this, sir. You'll be fine for a while. We'll show some stereo at the end. And the gateway, you can actually see that we have on our gateway and accessible through the library all of the mounted mount points on our system. So anything like a SAN or a NAS or even a USB drive with a scratch disk of RED files can be attached to the system. You can also use what's called a selection set, so you don't have to constantly go back and look for these different mounted volumes. And I can just quickly select my RED media. And now when I step back out of the network, you'll see that I have, over the gateway, a networked attached volume. If I go into the library, you can see that I can browse the files over that network. So it's a very visual way to bring things in natively through the system. If I swipe over to the right, you can see that we're actually able to bring things in and review things like the metadata. So if I double-click on this file, you can see it automatically tells me the format. So it's an R3D file. Here are some of the other options that we can bring in. And I can take a look at the metadata over here in a new little player for it. I can also do things like set in and out points for any of these different clips. So we can go in and limit the amount of content that we want to bring in this way. The other thing we can do is decide, as we're importing these files, to store local copies of them. We can also choose things like the debarring settings. So we decide what quality we want to work with. So let's say we initially want to work with a quarter res quality for these red files. And of course, we can also adjust things like the color settings. Notice if I go into a dual view now, and I switch to an empty library called red import, I'll reselect this file and say, let's just drag and drop it into my import library. And now when I select that clip, you can see it's telling me it's doing a pending render. So it's actually pulling that in transparently here for me with a very gestural way to bring things in, just a drag and drop. If I double click on it again, notice a button pops up calling Import History. This allows me to work with my files at lower resolution, maybe for doing my creative cut. And then once I've decided on the actual limiting the footage to what I actually want to use, I can go back and modify the import history to work with the full res media. And once I apply the changes and reselect that clip, over here in the player within the library for my gateway attached volume, you can see I've got my media now at full res, in this case 2K. Of course, we could also work with 4K, that's no problem. Now if I load that to my desktop and start to play it back, let's put that in loop mode, you can see that very quickly what we're doing under the hood, transparently to the user, is we're both importing and storing a local copy of that footage over that network. So again, as I'm working, it's actually caching this file locally for me, and it's all in the background. I don't have to think about it. So again, really improved media access has been brought into the application through the library and the incorporation of the gateway into the library. Now, the next three things I want to talk about and focus on in this part of the demonstration is all around the quality improvements in Flame 2011. And these improvements come in the form of things like pixel shaders. So a whole new architecture has been incorporated into what we call Action. Action, again, is really the heart of the system, and it allows us to do 3D compositing. And so I'm going to start with a simple example. We'll bring our red file into Action. Notice the resolution is slightly different than my project resolution, so I'll just quickly set that resolution of Action to our background resolution. So now we're at 2K 12-bit. And again, we're still bringing that file in through the gateway. All right, so let's get into an explanation of pixel shaders. So if I add a light into the scene and just do what we used to standard, this is standard stuff that we've always done. I'll increase the intensity of the light. I'll change the spread of the light. Kind of point that toward our actress here. And again, if I change the intensity, you can see that I've got a lot of range here. You got basically dealing with unclamped lighting in the application. There's a new menu within the lights to actually change the profile of the lights. So if I go into an add mode, I can actually add points to that profile. And notice I can create different types of lights. In this case, something like a flashlight. I can just create that on my lights directly, which is great. Let's go to the surface level now and enable shine. And this is what's new with the new pixel shading architecture. The quality of the lights is dramatically improved because we're no longer tying the lighting quality to the resolution of the surfaces and the 3D objects that we're working with inside of Action. We're actually working in a one-to-one mapping of the pixels, which is great. If I go in and change something like the specularity color, you can see that that quality is really going to come through. There's another new feature called the working camera, and if I just switch to the working camera and zoom out, you can see at any time, just like I would in Maya, I can actually look out at my scene from a different angle. So you can see now we're looking at our whole scene, but from the viewpoint of another camera. And if we go back into a schematic view while we're viewing through the working camera, I can now attach to any of my surfaces particular shaders. So there's an object here within the Flame bin that allows me to work with different shading algorithms. So you can see we have standard algorithms like anisotropic, and as I start to adjust it, you can see on the surface how it's making a different look to my image, and it's really giving me a nice subtle quality. So now the lighting is going to look very different inside of Action. If we go back to this surface and even turn it from a flat surface into an extended bicubic, I'll subdivide that surface, grab this handle. You can see as I bend that around, just exactly how the shading is actually going to affect that. And again, go back to the shader. You can see that the quality, the adjustments, it almost looks like you have a glow effect on the surface. And there's many different types of shading that we can use, Cook Torrents, Car Paint, and we'll take a look at these as we go through the demonstration. But I just wanted to introduce you to this, these few new features, but mainly the concept here of the new pixel shading architecture, which has had a huge impact on all parts of the Action module. So let's get back into our batch schematic, and I'm just going to bring up another example which talks to or speaks to this quality in terms of a comparison between a surface, like a bilinear surface. So I'm going to enable a wireframe view. So you can see on the left we have our bilinear surface. On the right I have a geometry. So we see polygons and also our resolution here. But when we get out of wireframe mode, you can see that the lighting within Action is going to be exactly the same. So we no longer have to worry about cranking down the resolution to try to get higher quality out of our Action module. All of our renders now are going to look much better because we're working with the new pixel shader architecture. So you can see as I move my two lights, the look is exactly the same. So we're able to get much more consistent lighting results out of Action. And if I orbit around, you can see that essentially I'm just working with bent surfaces to achieve that. Another nice new feature came into Action, which is related to the 3D path. So let's start by making some 3D text. I'll change the text. Let's just use something like a long string of eyes. So I'm just going to create a lot of geometry here to show you this next feature. We'll resize the geometry a bit, give it some depth, and add a light into the scene. So you can see now I'm lighting the geometry, but I want to move that back quite a bit so it's going to hit that entire string of text. So let's move this back a bit. We'll also move it up. And now when I go in and select the geometry, as I rotate that around, you can see I'm lighting everything that we see in front of that. So let's go back to the light, actually. Let's split the views and grab the light and change the intensity again, so brighten that up a little bit. And on screen on the right, I'm going to create a 3D path. So just by holding a hotkey, I can make any kind of path shape that I want. And then what's great about the 3D paths, and this came in a few releases ago, but we continue to improve the functionality. Here you can see if I attach anything to that path, it's now going to basically put any object on the path. These could be images or 3D objects in this case. And the other thing that's nice is anything on the path will align and stay on the path. So it's an easy way of kind of creating a path for anything that you want to put on that path. The other thing we can do is apply things like banking. I can adjust the angle of the banking and create whatever angle I want along the path. If we bring another axis into the schematic now, you can see, let's actually bring a few more axes. Let's bring in 4 more axes. And we'll just start to connect these up. So just by doing a little bit of parenting, a little bit of duplicating, and then connecting across these objects, I have the possibility in the 2011 release of actually doing instancing on 3D paths. So this was a user request, and it made its way into the application in 2011. So again, we like to listen to our customers, and when they give us feedback, we try to get those types of features implemented into the software as soon as we can, and the 2011 release was the time to do that. I'm going to adjust the intensity of my light a bit, go back to my geometry, go to the character axis and start to change the size of the characters. Notice with the instancing, everything is actually scaling all together because it's instance. I can change the rotation. I can start to play around with all the individual things here. But notice what I'm trying to do is create some angles that are kind of nasty angles and things that create a lot of aliasing on the edges of my 3D text. Well, another great new feature, and it speaks to the quality improvements inside of Action in this release. Inside of Batch, you have the ability to utilize hardware anti-aliasing. So notice hardware anti-aliasing options go from no anti-aliasing all the way up to 32 samples. And just by turning on 4, you can see we've dramatically, I'll turn it off again, we've dramatically improved that. So again, taking advantage of the hardware. This is just commodity hardware. It's not special hardware that we are creating ourselves. This is actually using the NVIDIA graphics card and harnessing that GPU power that it has and delivering this higher quality. And again, I can go all the way up to 32 samples. I'll just leave it on 4 for now and go back to the geometry and start to make my adjustments again. And you can see, depending on whatever angle that I use, I'm always going to get the highest quality out of my edges. So that's probably one of the most dramatic new features, and I'm sure everyone watching over the internet is going to enjoy that. Lastly, I'll just take that action node. I'm going to just add externalize a layer and take this still frame image and bring that in. I'm not going to use it as an image, so in the schematic, I'll just throw that away. And I'll introduce that now as a projector. So a texture projection is just going to be applied now. I'll attach that to my camera so we can see it a bit better. Let me split the the views, and just grab that projector. And let's go ahead and change the blending mode. So right now we're working with just a blend, but I want that to be a multiply. That way we'll be able to see it mix with our 3D, and we'll go into the lights and change the intensity of the lights. And again, as I start to move the projector around, you can see that I'm able to interact with our 3D instance text very easily, even with our hardware anti-aliasing set. And you can see that I can interact with that just as I would normally with any action scene. So the point here is that we wouldn't want to introduce any of these new quality improvements and then compromise the speed of the application. Because Flame is all about a very fast interactive 3D experience, that's what we wanted to do in this release. Introduce these features, but never compromise that Flame experience. That's what it's really all about. So let's go back to a single view. Let's get rid of what we've started with so far and continue our conversation with another example. And we'll do a little tour of what we like to call maps. So new types of mapping have come into action as well, again, taking advantage of the pixel shading. So under the object area of action, you'll see there's a few new tabs. So all of the objects are listed here. We also have a new tab for the surfaces, so they've sort of been divided into a new category, and then we have new maps. The old maps have actually been reworked as well. So I wanted to take you through a couple of examples of what I mean by that. Let's start with displacement. Displacement's probably the first feature we ever demoed. It's a great tool, and it's always been really cool in Flame. If we just start to extrude the luminance values in the Z orientation to the camera, you can see we can pull the luminance out and just create a displacement map. So if I start to pull this around, you can see it's pretty standard so far. But look what happens when I go in and I say, let's take our image and bring in a light and pull that light back and adjust the shine on the surface. Again, it starts to look very different inside of action. And that's really what the pixel shading architecture is giving us. It's the ability to take what used to be looking at a lower quality, I would say, somewhat lower quality, and you can see now the quality is so improved that we're getting very photorealistic lighting from our pixel shading architecture. And if I go back to the image here, we start to adjust the resolution. Notice that we're no longer tied to the resolution of the object. The specularity will always look the same because we're using our pixel-based architecture. If we go all the way down to a very dense mesh, you can see that we're still able to create a nice specularity. Even in wireframe, you can get the point of that. So I think that's a pretty good example of what's going on with the new look that's going to be generated. The lights have become much more subtle in this release. Let's go back and delete what we have so far and continue the conversation about the mapping. So we've had displacement map before. We've also had reflection maps. But let's attach a reflection map to the scene and talk about how they've improved with the pixel shaders. So let's go in and just orbit the camera around. So there's a standard reflection map. That looks pretty much the same. But notice there's new controls for the reflection map. There's things like an effect and a softness parameters where we can do GPU-based softness. If we go into the texture menu, there's new options like mirror repeat. So if I bring the scaling down on the mirror repeat, let's bring that down to about this size. Now we're actually able to repeat that texture, and in the repeat mode field, we can actually change replace to additive, and now we're getting a proper reflection. So that's starting to look pretty cool. Let's continue on and again include a light in the scene. We'll bring the light back, and again, through that light, you can see we're getting a really nice reflective look through our new pixel shader architecture. All right, so that's the new reflection maps. And again, I'm just going to turn off the shading for now and delete what I have so far to continue the tour of the new maps. The next one I want to talk about is diffuse maps. So diffuse maps, they're not really new either. They've just been renamed. They used to be called wrap textures. Now they're called diffuse maps. And again, all the same tiling options exist. So if I wanted to tile this out, instead of mirror repeat this time, we'll just do a standard tiling. But notice if I go back to the controls, I have the ability to adjust the gain on any of these maps. And again, we're doing that gain across multiple tiles all at the same time. And if I adjust the softness, same thing. And these are based on the GPU performance, so that scales a lot faster and better than the CPU performance, which is the way we were doing blurs before when we were tying them to the media layers. So CPU versus GPU, GPU is always going to be preferred. So again, you can see that we're now taking advantage of that commodity hardware to deliver better performance for things like blurs. And again, it's a quality issue as well. All right, so let's throw away that and talk about some kind of maybe underlying, maybe unintended effects that can be derived from using things like diffuse maps with different resolution textures. So let's go ahead and add in just at first to show you the difference. We've got in the background we have our balloon image there. That has it's a film image at a ratio of 1:37, so we're talking about square pixels there. And I've added in an image that has rectangular pixels at 178 at a different resolution. Look what happens when I add that in as a diffuse map. It's actually mapping that across the square pixels correctly. And if we go in and do what we were doing before, let's turn on our tile repeat. Notice that under the texture, there's different options, things like cropping options as well as resizing options. So let's go to our front view for that media layer and enable a crop. And as I start to adjust the cropping on the front of that layer, notice I have a choice on how I want to do the crop. Notice the axis stays in the center unless I turn that off. And now I'm going to have, I'm just going to move with it. So I can basically center my axes if I want to, or I can just use that cropped on or off. So that's pretty cool. Under the mapping choices, we also have something called perspective mapping. So this is another really nice feature. It allows us to take our scene. Let's scale this down quite a bit. You can also scale that down, something like that. And then we'll just rotate with our perspective mapping, we're going to rotate that back in perspective. So you can see with a very simple construction here in the schematic view, we're able to create a much more interesting angle there for with our perspective mapping. So again, it's a pretty nice little trick to do things like that using a different resolution texture, diffuse map attached to our initial film image. This also brings up the point that we've introduced a third quality improvement within Action, and that's also using new filtering options on the surface level. So again, anisotropic, EWA with linear. EWA is elliptical weighted average, and what that's going to allow us to do in situations like this is where pixels are actually sharing the same physical location on the screen, it's going to basically avoid having the ringing or the noisiness that you would typically see out of renders where pixels are actually kind of overlapping, which is a great new feature as well. All right, so that's kind of an interesting trick, and it kind of gives you some insight in how the maps work and basically this new behavior that's been introduced. So again, redesigned in terms of interface, reworked under the hood for the old maps, but there's also a few maybe sort of historical things that got fixed. So if we re-add this image, let's reset the crop, re-add the image, and I'm going to jump into the keyer, and I'll quickly create a key using the master keyer. Right? If I look at the result, you can see I can also add a patch. So we're going to clean this up with a patch, maybe extend this out a bit, and also create a garbage mask. Right? So I'm just going to quickly draw a garbage mask around there. Maybe pull these points down. And let's put the color down. So there's my garbage mask and my key. If I go back to the surface level, notice that every one of the transfer modes or the blending modes has now the ability to work with full transparency on each of these individual settings for my blending modes. So let's go in and blow this up a bit more. Let's switch to a multiply and slide that over a bit so you can see what I'm doing a bit better, and just walk through the various transfer modes. I'll do that here at full screen so you can see what's going on. So for each of the transfer modes, I'll just walk through Spotlight, Spotlight Blend. You can see Simple Add. So all of the transparency settings work properly with mattes in the 2011 release, which is great. And again, another thing that came from implementing the pixel shader architecture was the ability to kind of clean up and fix some of these historical issues that were long-time complaints from users. And we're not afraid to say that, you know, we heard you loud and clear, and now these types of things have been fixed in 2011. So it's a great reason to stay on subscription, is to kind of get all these like goodies that that come in when you're upgrading. All right, so I wanted to talk about some more things. Let's actually move on to a conversation about the new maps. So let's go into an example here, which is going to talk about some of the new maps. I have another setup that I'll just jump to quickly. This again came to us from McRae Lab in Japan, and we're going to use this to explain the new maps. So let's start here with parallax mapping. I'll add in a parallax map. Let's switch to this view, kind of a one-up view now, and notice as I start to adjust the scaling of a parallax map, the effect that we get is almost like that predator effect. This almost needs a sound effect, like a right? So we'll go ahead and bring the scaling up on the parallax map. We can adjust the bias as well, kind of push down the pixels a bit. We can soften that out a bit, and we're starting to create a very sort of 3D look out of a flat surface with a parallax map. But look at this, it's actually almost an optical illusion. As I start to rotate that axis on its side, it looks 3D until I turn it all the way on its side, and it's actually completely flat. And that's what's so cool about parallax mapping. We've actually started to take techniques that are used in game engines and bring those techniques into action to allow us to do things at very high speed, at very high quality, and create very realistic 3D looks out of our mapping algorithms, which is cool. The other thing we can do is go here and turn on things like relief mapping. This even shows it better. It really looks 3D until we turn it all the way on its side, and it's, again, borrowing heavily from techniques in game engines. This is really, the quality just keeps improving, and we're implementing those techniques now into action, which is really, really cool. Let's go back to our 2-up view. We're going to throw away the parallax map. But really the best way to show the new maps, because we've got emissive maps, specular maps, we had normal maps before, but the quality looks so much better now with the pixel shading architecture, and you'll see that. But the best way to show this is actually with a new node here. It's just one little object in the map bin, but when I double click on it, it actually represents a whole bunch of new substance textures. So procedural textures have been included now in the application, allowing us to apply very photorealistic looks to either objects or surfaces. Let me show you what I mean by that. Let's say I want to go to one of the submenus like ground. Here's a whole library of photorealistic textures. I'll select the one called sand. And now you see something that looks pretty boring at first, but let's kind of review what we've talked about before. Of course, I can repeat any of these textures, so I'll go to the diffuse map. I can either mirror or tile repeat. We've seen that. I can go to this construction and show you there's also a shader attached. So we talked a little bit about the shaders. So depending on what you're using, you've got now attached with one substance texture, multiple maps as well as a shader. Let's go and add a light into the scene. And notice as soon as I add the light, the look completely changes. Now we're talking about a much more photorealistic look. And if I go in and take my axis for the overall scene and I rotate it as I was doing before, rotate that on its side, again, we're using that same technique we talked about that would be used in a game engine to apply something that looks incredibly photorealistic, but with a very limited amount of polygon and overhead in our scene. Of course, the point of all this is that we can mix these textures with surfaces. I also have different materials that I can use. I can change like the dunes themselves. I can change the shape of the dunes, things like that. That's kind of cool. I can also change the hue and things like this. There's a lot of different controls. But look what happens when I take this surface and I add it in as an image. And then I just go ahead and take an axis and I bring that in as well. And I parent the axis there down to the normal map. Now I'm starting to combine that surface with that texture. And that's what's really cool. Let's go in and attach it this way. Maybe bring that light back a little bit. Bring it its intensity up a little bit. Something like that. And now as I start to move the axis around, you'll see that we've got something that looks really cool. And again, if I turn it on its side, it's just flat. So it looks really good. You can also do the same thing with our parallax map. So let's go back and add another axis into the schematic. Same thing as before. I'll parent down from the image and down to the parallax map and start to apply some scaling to that. And again, you can see I'm creating something that looks very 3D. Let's adjust the bias as well. Maybe take that up a bit more. But as I rotate this around, everything is an optical illusion. It's actually not in 3D. So again, this is just a whole new engine. Allows us to do some really cool things with a very low overhead on our scene. it can be combined with multiple images. So let's bring in another layer. Let's reset the axis there. We can zoom in a bit. We'll move this layer over a bit and take our light. So we're now got the light hitting both of our objects. And just by simply parenting here in the schematic, you can see I can apply very quickly, I can apply that same type of surface now to the other layer. And if we orbit around, you can see now we've got something that looks really cool. So again, we're talking about a lot more photorealism brought into the application with the substance texture maps. And it doesn't end there, of course. If I go back to the schematic and I parent down to the parallax map, now she's combined with that surface. And it gives us almost like a sandpaper type look on our images. If I were to start to move this axis, you can see I'm moving it. It really is at this point almost like a cutout. I'm just moving her as a cutout across our scene. But what if I wanted her to be embedded into the texture? Well, this is where using the maps is going to become very interesting, because if I add her again as a diffuse map, let's orbit our camera a little bit more. As I move the axis for the diffuse map, now she's physically inside of that texture. And again, the whole time that we're working with all of this, it's all really just an illusion. So that's pretty cool. I really think that's neat. And again, this is for moving images as well. Now let's say we wanted to take this a bit further, because we're just starting with our standard sandpaper look. If we go back to the initial image that we started working with and we adjust the shine, we can actually turn that sort of basic sandpaper look with an adjustment of the shine value and its relationship to the position of the light. We can turn this into what almost looks like an oil painting. And again, if we bring down the hardware anti-aliasing, it's going to look even higher quality. And of course, we can duplicate that shine value to the foreground element, and that looks pretty cool. But let's say that I actually don't want to affect the woman in the scene. I don't want her to be part of that particular sort of look that we're creating with our oil painting. I can go back to my objects and attach a shader now to her surface. And again, a long time feature request from users, is there any way that we can have objects in our scene that are not affected by the lighting? Again, we can do that with our shader. We can simply say turn shading off for that surface, or we can start to combine looks based on the types of shaders that we begin using. So here, if I use an anisotropic shader on her, you see I'm getting a different effect. And if I go back to the shader itself, as I make adjustments to the shader, you can see it's going to have a different effect on that surface. So again, shaders are amazing, the substance textures are amazing, the whole entire application has been rewritten under the hood. It's as big a release as, including OpenEXR workflows or multi-resolution workflows into the application. Literally every single tool had to be adjusted and thought about when it turned into adding this feature into action.